is the final setup for the speed control method of DC shunt motor. First of all, we are going to see the field control method. We have to understand the basic thing about the speed control or the speed regulation of the DC machine. We know that the back EMF EB equation is phi ZNP by 60 into 8. Okay, where the phi is the flux per pole, Z is the number of conductor, N is the speed in RPM, P stands for number of poles, 60 is a constant, and A stands for number of parallel paths. If you want to put or if you want to find out the speed with respect to all this condition, then if you are making the speed as a subject, then equation of the speed is going to be N is directly proportional to the back EMF EB and inversely proportional to phi. Now we all know that the flux phi per pole, that is directly proportional to or directly dependent upon the field current IF. So I have substituted the phi by the means of IF. So this is the overall equation of the speed which is directly proportional to the back EMF and inversely proportional to field. Right now we have to check our speed variation with respect to the field current. So here we are dealing with right now the field control method, means this. Here we have to take the readings of the field current IF and speed. As far as the setup is concerned, here we have supplied the 220 volt to this motor right now. Here this is our rheostat which is connected in series with the armature. I haven't set it to 0. It has somewhat amount of resistance. This is our field current IF. Right now we are interested in the reading of this. This is the rheostat which has been connected in series with the field winding IF. Now what we are going to do, right now the field winding rheostat that has set to 0, I will step by step increase the resistance of this rheostat. So the field current IF is going to reduce, and as the field current will reduce, the flux phi will reduce and our speed will increase. So periodically we are going to increase the resistance by the means of this rheostat. We will decrease the field current and we will increase the speed. Overall these readings we are going to take now. So first step, right now you can see that the rheostat has been set to 0. I am increasing it somewhat, but before that let's verify the speed. Let's verify the speed. Right now the speed is so as of now, right now we can check the speed. If you are going to measure here, it is 1130. So right now the speed is 1130. At that time, what is the field current is? Field current is 0.9 ampere, as we can see that. Field current is 0.9 ampere. Now we are increasing this resistance in the field. As you can see that previously the field current was 0.9, it has been reduced. It has been reduced to 0.7. So now the field current is 0.7. So the speed technically that must has increased. So speed is 1225. The speed has been increased to 1225. Similarly, now we are going to keep on increasing this rheostat resistance of the field winding. We have increased the resistance, so we can see that the current field current has been reduced. Field current has been reduced to 0.6 ampere. So now the speed is it is 1310. Speed has been increased to 1310 RPM. We'll continue this process. I will keep on increasing the resistance. This time the current is 0.5 ampere. And the speed is exactly 1400 RPM. Speed has been increased to 1400 RPM. Now again increase in the field resistance. Again increase in the field resistance. Now the current has been reduced to 0.4 ampere only. So the speed has been increased to 1520. Speed has been increased to 1520 rpm. Now I am again increasing the so I have put in my rheostat at its maximum position and my field current has been reduced to 0.3 ampere only. So right now my speed is 1770. So as per reading we can see that as our field current is reducing, our speed is increasing. It is following this equation where speed is inversely proportional to field current. Thank you.